All right, today we are diving into one of the wildest, most mind-bending ideas in all of cosmology. We're going to hunt for something that's strange, incredibly powerful, and might just be woven into the very fabric of reality itself. We're talking about cosmic strings.
You know, we spend all this time and energy looking for some mysterious particle to explain dark matter. But what if the answer isn't a thing at all? What if it's a fundamental defect, a flaw left over from the fiery birth of the universe, woven directly into reality?
So, let's put on our detective hats. In this explainer, our number one suspect for some of the universe's biggest mysteries is an object that is as elegant as it is bizarre: the cosmic string. Okay, so to really get what a cosmic string is, we have to talk about this concept, a topological defect. It sounds super complicated, I know, but you can basically think of it as a scar. It's a stable, lasting flaw, not in some material, but in space-time itself. And it was created during this incredibly dramatic moment in the early universe called a phase transition, a point where the fundamental rules of physics literally changed. To make this idea a little less, out there, think about this. Imagine a lake freezing over. As the liquid water turns into solid ice, that's a phase transition. And if it freezes really fast, you get all these imperfections, these cracks, locked into the ice. While topological defects are basically the cosmic version of those cracks. So a cosmic string is one specific type of these cosmic cracks. They're thought to be one-dimensional, which means they have incredible length, but are basically zero thickness. I mean, they could stretch across galaxies, be thinner than a single proton, and yet they contain a mind-boggling amount of energy, all held under this insane tension. Basically, all the energy of the early universe in that one spot got trapped inside that tiny line. And here's what makes them so powerful. They have so much tension, so much concentrated energy, that they don't just exist in space-time, they actively warp it. They bend the universe around them. Each and every string carries its own powerful gravitational field. Okay, this of course leads to the next big question, right? If the universe is really filled with these incredible structures, what process could have possibly made them in the first place? Well, the leading theory is called the Kibble mechanism. Let's go back to our freezing lake. Right after the Big Bang, picture the universe as this perfectly uniform, super hot soup. Then, as it expands and cools, it goes through that phase transition. Different patches of the universe start to freeze into a new state, but they do it independently, kind of like ice crystals forming with different orientations. And where these misaligned patches, these domains, meet, they can't line up perfectly. So a flaw, a cosmic string, gets trapped right there at the boundary.
And this didn't just happen in one little spot. This could have been happening all over the early universe, creating this vast, sprawling network of ancient defects, crisscrossing the entire cosmos like some kind of unbelievable energy web.
Okay, so we've got a theory for how they were made, but how on earth do you actually find something that's billions of years old, thinner than an atom, and totally invisible? Well, our investigation now turns to the hunt for cosmic fingerprints.
It turns out astronomers have a few really clever tricks up their sleeves. There are three main ways we're hunting for these elusive strings. We can look for the ripples they make in space-time. We can watch for how they bend light from faraway stars, or we can look for the faint signatures they might have left on the afterglow of the Big Bang itself. First up, gravitational waves. See, these strings aren't just sitting still. They can wiggle, they can vibrate, and they can even form loops that oscillate like crazy. And as they do all that, they radiate energy out into the universe as gravitational waves. Future projects like LISA might be able to pick up this faint, constant cosmic hum coming from a whole network of these strings. The second clue is gravitational lensing. This one is really cool. Because a string warps space-time so much, it can act like a lens. So if a string happens to pass between us and some distant galaxy, its gravity would bend the light from that galaxy, creating a really peculiar, very distinct double image of that one galaxy. If we ever find a pair like that, it would be smoking gun evidence. And finally, we can look at the cosmic microwave background. It's like the universe's baby picture. A network of cosmic strings would have left very subtle temperature patterns in this ancient light. Now, we haven't found a definitive signal yet, but believe it or not, even not finding something is super useful here. It tells us that if strings do exist, they can't be more massive than a certain amount, which helps us narrow down our theories and focus the search. So that brings us to the most important part of this whole investigation. What's the bottom line? What are the stakes here? Why does finding these things, or not finding them, matter so much to how we understand the universe?
Well, the stakes could not be higher. On one hand, if strings are out there and they're abundant, they could be the answer to dark matter. They could be the gravitational seeds that the very first galaxies formed around. They might even explain some of those mysterious gravitational wave signals we're picking up. But if they're rare or not out there at all, that's not a failure, not even close. It tells us a ton about the early universe, helping us figure out which of our big ideas are on the right track and which ones aren't.
So you see, in the end, the search itself is a total win-win. Pushing our theories and our telescopes to the absolute limit in the hunt for these cosmic threads makes us better scientists, it forces us to ask bigger, smarter questions, and it deepens our understanding of the cosmos no matter what we find.
And that really just leaves us with this one final provocative thought. Isn't it just an incredible idea that the solutions to the grandest mysteries in the universe, dark matter, how galaxies formed, might not be hiding in some new exotic particle, but are instead hidden in the most ancient, the most infinitesimal cracks in the very fabric of creation itself?